Hello, welcome everyone. I'm Elizabeth Joyner, Community Coordinator for NASA's Earth Science Data Systems, and I am thrilled to have you join us for part one of the Data Democracy Sessions, empowering everyone with our data tools and services. Part two will begin this afternoon at 1:30 Eastern Time to pick up where we leave off. One of the many reasons why I love ESIP is the core values of inclusiveness, and with that comes collaboration, which is where we will focus today's attention. It is important to note that discussing government policy or personal opinions about such things are not in the scope of today's session. Anyone discussing these ideas will be reminded of these policies. So let's kick off this session to learn about current Earth science data models of excellence for democratizing data for all, as they show us examples of how they embed inclusiveness and collaboration in their work. We will work at a very quick clip today. So here's the agenda. Notice that we do not have any breaks. So if you need one, please take one. And I will do my very best to keep us on track. I'll lean on Aaron and the team here, and I will attempt to provide 5-minute and 1-minute alerts to all speakers. We will have two interactive elements this morning. One is the Mentimeter survey that is found on the left, and the other one is the Padlet on the right. Please take time to open these now, and I will put them in the chat. We also have the Google Doc for this session, and I believe Joe will be, okay, we already have that. Thank you so much. So please sign into that as you are able. And so I see here, I've signed in. We've got a few. Okay, so good. We've got several who are signing in now. Thank you so much. And I'm going to copy and paste. Let's see these URLs into the chat. And so Joe and Aaron, as people come in, if you'll keep those populated, that would be great. So with this, we're going to go ahead and start now. Okay. So when you come into the Mentimeter, please, if you're able to, give me a thumbs up if you can, or if you run into any problems. Actually, I put into the chat to Leah, not to everyone. So let me try this again. There
Joe
we go.
just added them. Okay.
Thank you. Sorry about that. Thanks, Joe. You're awesome. All right. So please join the Mentimeter. We have this to collect a little bit of information about you and your background. And we will also return back to this Mentimeter at the end of the day. While you are getting access to the Mentimeter, I want to show you, I've set up a Padlet for us today. Now this is your space to share opinions and thoughts and connections to your work. And so can we see that on the screen, Aaron or Joe? Can you see the Padlet? Yes, perfect. Notice on the left, we have the various links to Sketch, to the Google Doc, to the Mentimeter. And then we also have these driving questions. The driving questions: what are the needs that non-super users have for accessing and making action with data? What current models are used to address these needs to help users access and use our data? What communities of potential users exist that we want to engage? And then how might we work together to leverage our assets to support these new users? So as thoughts come up, feel free to drop them into this Padlet. And then we also have a box of text for each of the presentations today. And then at the end of the day, hopefully we've got time in that session too, where we're going to do some breakout rooms and we're going to talk a bit about these questions. So with that, let's go ahead and get started. What organizational sector do you work for and or support? So far, we have 10 people who have logged in. I see we have 30 participants. So come on, guys, log in. We can do better than a third. I know we can. Thank you for that. Thank you. Thank you. I'm going to leave it for another 5 seconds or so. It's great to see the representation. All right, I'm going to move forward. Which of the following best describes the focus area of your research or applications? So we've got some ocean science folks here in the house. Other, love other, interested in that other. So if you are one of those, please put that into the comments. You should be able to access those. I'm going to move forward. What type of data user do you represent? So we have, okay, let's see here. We've got data providers, tool developers, researchers. All right, so we've got a nice swath of different types of users. So this is great. Even novice data users. So way to go, and science attentive public, very nice. Thank you so much. All right, so what does Earth data democracy mean to you? Accessibility, open data, access, minimize barriers, equity, open, fair, and care principles. All right, transparent search, fair and care coming up a lot. This is great. Ethical, equitable, build capacity, co-governance. All right. Which barriers prevent your users from using data in their work? Not enough time. Lack of technical support. Data are too complex or too large. Difficult to find data because there are too many resources available. Lack of requisite knowledge, skills, or expertise. What audiences do you serve with your data, tools, and services? Mostly researcher or scientist, undergraduate or graduate students, general public. Okay. All right. Very good. All right. We're going to stop there. So thank you so much for sharing that information, and continue to use that Padlet to collect your thoughts or your questions. And so with that, I would like to introduce Madison Broadle. Madison is a member of the Earth Science Data Systems GIS team, also known as EGIST, within NASA Earth Science. She serves as a GIS analyst for the team, creating GIS-centric resources such as learning documentation and conducting outreach to current and potential NASA data users. So, Maddie, are you ready to get started?
I'm ready.
All right.
All right. Hello, everyone. As Elizabeth stated, this is Madison Broadle, a GIS analyst on the EGIS-T team with NASA. I'm also joined by my team lead, Leah Schweizer. She'll be in chat as well as here for the Q&A session to help us answer any questions that we might have. And what we're talking about today is a program called Unbound. You're going to learn all about it, including what the acronym stands for later on, and how we're using it to help improve data discovery, access, and use at NASA Earth Science. So next slide, please. For our in general, who are we and why are we here? We're here to represent NASA Earth Science Division, whose goal is to provide decades of data to help in understanding our planet's interconnected systems from a global scale down to minute processes. As most of you are probably aware, the data that NASA produces is free and accessible for use by anyone and everyone, and these decades of data are offered to the public via a multitude of tools and services for viewing, accessing, and interacting with the data. And when we say data, click please, what we mean is, and this is the most recent estimate I could find, is over 100 petabytes of NASA Earth Science data. Click please. And that is a lot of information for our users to have to sift through to find what they might need. And our goal and our purpose on EGIS-T is to make this data more accessible via GIS tools and services. Next slide. So as you heard, EGIS-T stands for Earth Science Data Systems Geographic Information Systems Team. Click. And our goals are to maintain awareness of GIS capabilities and efforts across NASA Earth Science to encourage the development and coordination of GIS. Click. As well as build a community within NASA to create, publicize, and highlight GIS content to aid users in navigating Earth science data. To the right here, you can see some examples of that, such as GIS-focused tutorials or an effort that we did for GIS Day, where we highlighted various teams that did GIS at NASA so that the public could learn about them. And click. And additionally, we help to demonstrate the proper use and utility of GIS for NASA Earth Science by leading public-facing technical discussions, webinars, or workshops, as well as participating in events such as ESIP. You can see an example of one that we gave to the species distribution model community that was tailored to their needs and interests and how they could use GIS and NASA to solve their challenges. So next. So where do we generally engage? We most often go to GIS-focused conferences and workshops, working groups, or forums, such as the Esri Federal Conference or the Esri User Conference. Next. And while we're there, we conduct exhibits and expos, user groups, show workflows, demos, posters, presentations. Generally, when we have a NASA user group meeting at a conference, we have 50 to 100 users that come and engage with us, which is always very exciting. Very exciting to see that many people want to come hear what NASA is up to. Next. And then while we're there, we engage with direct one-on-ones. We conduct Q&A sections. We do live questionnaires similar to what Elizabeth started us off with today to get a sense of where our users are at. Click. And we engage with quite a wide swath of people. Our current and potential users are from government, private sector, academia, community groups, or NGOs, and click. And while we're there, we learn what questions they frequently ask. We hear their feedback, their preferences, what challenge or gaps they may be facing in accessing our data, as well as GIS-focused market trends or new technologies that we need to be aware of to best serve our community. Next slide. And at each event, we're very pleased to find that we consistently hear that users have overwhelming interest and excitement for NASA Earth observation data. Click. Generally, when we start, the comment we most often get is, I didn't even know NASA had Earth science data. And then, the next are generally, you have imagery, is your data free? Is it global? Are you in GIS data repositories, such as the Living Atlas of the World? Click. And then after they hear from us, the next response is, wow, that's a lot of data. And I can't believe that it's all free and global. And then most exciting, we do get people to say this is relevant to what I'm working on and that they're excited to explore more. Next. And to talk about the feedback that we generally get when we conduct surveys at these conferences, click. I will note that these are done at GIS conferences, so this stat is higher than maybe it would be at a more general Earth science conference. But then we have, 75% of the people that attend our working groups have worked with image services before. They are GIS users. Click. But we get a pretty even split on if they have used NASA Earth Science before, or Earth Science data before. We get a little bit of a majority for yes, but we have plenty of people that have never used NASA Earth Science data or are interested in using more. Additionally, we also get a sense of how they're accessing our data. Here are 4 of our main GIS-centric tools or main access points, such as Earth Data Search, our instance on ArcGIS Online, our imagery-based tool called NASA Worldview, and then our enterprise GIS instance, Earth Data GIS. Next slide. But we also collect information on what their challenges are, such as what's your biggest hurdle when working with NASA data. You can see here we have the categories we frequently reference, which are discovery, access, and use. And discovery, meaning how users learn about what data we have available and try to select from our vast archive, which is most applicable to their work. That's generally the biggest pain point that we see users experience. Next. And what challenge do they have in accessing? Again, in support of that, difficult to understand what variable, parameter, or data to use, or that our data is too large to handle. It's too difficult to download or process these massive data files. And in addition, once downloaded, it can be difficult to use in the GIS tools or apps that they're wanting to do their research in. And then how do they prefer to learn? How do we help make some of these things better? We hear time and time again that users love video tutorials as well as examples so that they could follow along, for use cases. Click. In addition to, then when we ask them, what do you want us to present at these future using groups, it's data duels and TIMOs, it's more lightning talks so they can learn what NASA even has available, as well as more tutorials and workflows. Next slide. So how do we start to take all of this feedback that we're hearing on that there are pain points and there are challenges and there are things that we could do to make our data better? How do we get those specific recommendations? So what features in this tool would aid in your discovery, access, and use? What specific formats are most valuable to you when downloading our data? How do we get those actionable recommendations from our communities? And NASA's Earth Science answer to that, one of the answers has been standing up a project called Unbound. Unbound stands for Understanding Needs to Broaden Outside Use of NASA Data. And what they do is they employ a series of coordinated domain-specific workshops. So, or even, you can think of it like subject area-specific workshops designed to match influential analysis and visualization practitioners in target communities with then the relevant NASA data scientists / others knowledgeable in the field. We've conducted 5 so far. If you'll click, you can see 3 examples of ones that we've conducted. We have the species distribution modeling community. We had one for coastal issues. We had one for air quality. And you can see here that the air quality one, the facilitation engagement was led by ESIP, by members of this community, which is pretty cool. So then next slide. So when we talk about why Unbound, why this approach, throughout our engagement over the years, we've seen significant interest and opportunity to connect with new user communities. We're hearing from users that they want the data, tools, and learning content tailored to their community, their tools, and level experience. You can see an example of that here on the right side of the slide. This is a screenshot from the Earth Data website. So NASA's Earth Science website, where you can find information all about Earth science, that you can see that we have information grouped by topic, such as atmosphere, biosphere, climate indicators. And these are here so that when users click on them, they know that they're getting content tailored to their community, whether that be articles or data recommendations or tutorials in some cases, so that they feel the content is more approachable to their needs. And then next, we're also hearing that there's an increase of demand in users who fall outside of the previously typical NASA data user. The previously typical user would be that research scientist or a PhD subject matter expert, but the category of general public year to year is increasing. You can see here from the Annual Customer Satisfaction Index survey, the ACSI, that this is from 2021 to 2022, but that general public category is increasing as time goes on. So those are users that may not have been interested in NASA or science before, or may not have found it approachable enough to even try, that are increasing in number. So click. So with that, the idea to broaden that outside use is what made Unbound a reality. It's what NASA said, this is a gap we can try to fill, is meeting those users, these people that want content tailored to their communities and may not represent a typical user. And Unbound can help start to solve problems and fill in gaps for that type of user. Next slide. So, and I wanted to note that Unbound is very mindful when selecting participants for these workshops. The goal is to get a diverse team that come from an expansive range of backgrounds. Generally, the split between, what type of, have you worked with NASA or science data before? It's usually a range of like experts to novices, never heard of it. I'm just an expert in this community, which helps get that diverse background and feedback. Additionally, you can see an example here from one of them, the species distribution modeling workshop, that they also are a global community and that they come generally from a diverse range of backgrounds. So you can see here that academia, NGOs, Fed, Gov, private is all represented with in this coastal issues workshop. Next. So now we're going to dive into some of the more specific feedback that we've been given at these Unbound events. But I wanted to highlight this quote here, which I think, again, hits home the point that meeting communities where they're at is seen as very valuable. So NASA has an enormous amount of amazingly useful data, but being aware of, locating, obtaining, analyzing this data is still challenging for most people. Workshops like this can both help users understand the scope of NASA's data offering and help NASA address the complex challenges of providing such large and diverse collection of data to such a large and diverse set of users. So next. To help make this feedback more approachable and ready to be actionable, we've broken down a lot of the feedback we've received into these 5 main categories. Again, you've heard these, me say these several times. We have data availability, which is do we provide the data that they need? Data discovery, how are they learning about what we have? Data access, how are they finding and downloading? Data use, then are the files or what they download set up to then be used in the programs that they want to do their research in. And then we have the all-encompassing outreach, training, and resources. What learning resources do we have to help make all of these steps easier for our users? So next slide. To start with the data availability, workshop attendees were asked questions like, what satellite data, maps, or Earth data or imagery do you think would be helpful to you? And then you can see here, the bottom image says what like category of data is most useful in your research, such as you can see like vegetation matching was something this community was very interested in seeing data for, or precipitation data. That way we get a sense is NASA providing the data at a time scale, at a frequency, at a location that users are looking for within their research. Next. Next, we have data discovery, and click again. So we have what barriers are preventing you from using NASA data in your work. Far and away, we see lack of familiarity or difficult to find the data, difficult to understand the data. Next. You can see here that even when you search, even if you know what specific mission you're looking for, it can be overwhelming to know, okay, 13 matching collections came up. Which of these are the ones that I'm looking for, or over the area that I'm interested in, or available over the time that I'm interested in? Click. You can see here that this user identified that when I click Get Dataset, they're taken to a page where there are 197 options with titles that aren't human readable. And maybe they don't have descriptions, and the user then doesn't know what it means, and then they can get overwhelmed. If I don't know which of these is the right one, maybe they select none of them. So that data discovery is important to helping users not feel overwhelmed and feel like they're making the correct decision. Next slide. Next, we have data access. This is in reference to, we have various tools and services and learning pages that we have offered to the public, but which of those do users actually find easy to use? Do they find approachable? This gives us an opportunity that if a certain tool has features that users find easy to use or accessible, are there things about that tool that could be applied to other tools? Are there things about those learning resources that we should consider including in our other types of learning resources? Next. And then go ahead and click. And click again. So again, that data use, if users have difficulty understanding the data, they can have difficulty understanding how they should use it. In addition, often if it's in a complicated file format that isn't easily readable by the tools that our users are using, then it can make it challenging to employ that data in ways that they find valuable. So users have made suggestions that they would like to include the use of standard formats such as CSV or JS-friendly file types to make it more straightforward when downloading and using. And that they recommend having standard subsetting tools to provide a more easy download experience. So that way, once it's on their desktop or on their computer, it's more easy to use the data. Next. And next again. And then for training, outreach, and resources, users are reporting that they would find training important to them, that having training opportunities where not just static videos, but online training opportunities where they can have opportunities to ask subject matter experts, what can I do differently? How can I improve this process? What am I missing? Having that guidance given to them so that they feel more empowered to then tackle the data and do their research. Next slide.
5 minutes, Maddie.
Perfect. So we are the eGIS-T team. GIS is in our name, and we do see GIS as a solution to a lot of these problems. This is another screenshot from an Unbound workshop. When users are asked the question, how are you analyzing your data? You can see here that some of the top responses are ArcGIS, QGIS, Google Earth Engine. The users are using these GIS tools, and if you could click, you can see here, and again, please, that this is another screenshot from an ACSI survey that, again, ArcGIS and QGIS are the tools that our users are using. So to meet them where they're at, because they're reporting that GIS-friendly data tools and services are of importance to their community, they're looking to download data in GIS-ready formats, and they're looking for NASA data within these larger GIS data repositories, such as the Living Atlas of the World that we mentioned earlier. To meet users where they're at, these are some ways that we can check those boxes for them to make our data more accessible and improve pain points along the categories we talked about earlier. We have seen a positive response to this because in one of the Unbounds, a user noted that it was great to see NASA making more resources available in GIS and available within the Living Atlas. Next. So we do have some examples of starting to implement these recommendations. So we have enhanced customization options within our primary data download tool called Earth Data Search, allowing users to subset, meaning that they can subset by their area of interest, by the time they're interested in, and even the particular variable they're interested in. So they're not downloading these massive files full of information that isn't relevant to their research, as well as reformatting options so that they can be made available within easily available within GIS services. Additionally, we have things like Smart Handoff. So our data viz tool called Worldview, users can view the data and then be given a smart handoff to Earth Data Search to then more easily download what they've just viewed. We're increasing the number of authoritative NASA image services within the Living Atlas. We have the Earth Data Forum, which is a place where users can directly connect with subject matter experts, and we have a tag specific to GIS tools and help content, as well as improving and expanding on our GIS-focused tutorials, including tutorials for open source tools on our web pages. Next slide, go ahead. Yeah. And then, so internally, what are we doing? So we're working to consolidate all of these recommendations and organize them into the categories that you saw previously. That way, then we can more easily share them with NASA teams who can address those recommendations, get those recommendations at the hands of the people that can make these improvements. And then what we want to do is we want to let users know about those changes, improvements. We want to identify and gather implemented changes that were informed by Unbound feedback, and then determine a plan to share those out with Unbound participants as a way to say, thank you for your time. Thank you for telling us how we could make these things better. And this is what we've done to help. And next. So if you're looking to engage further, we encourage you to go explore these Unbound pages to see, to dive into our community's tailored recommendations. Yes, they're specific to NASA tools and services, but I think that a lot of these pain points can resonate across users for lots of different services. If you're interested in hosting or participating in future Unbounds, if you have a community that you're looking to work with NASA to do this outreach and information gathering from, we encourage you to contact us and reach out. These slides will be shared afterwards, so you can either take a picture now or get it then. But if you're interested in hosting, we'd love to hear that and see if we can work with you further.
1 minute.
Next slide. And with that, please let us know if you have any questions. We're very passionate about this, making all of our tools and services and data easier for users using that GIS lens. So we're happy to answer any questions you might have, and we look forward to engaging with you more in the future. And with that, that's all for me.
Wow, right on time. Good job, Maddie. Hey, Maddie, I encourage you to take a look at this Padlet. And there were a couple of comments that came up in the driving questions section. And please do respond if there are any questions there. I saw Nate, who's one of our speakers here. Nate, you had a comment specific to this session.
Yeah, I don't know if you're handing it off to me to
I
start the next.
am. Yeah, I'm
Okay,
sorry.
perfect. Yeah. Yeah, I put in the comments there, Madison, that I think users in the ESOL and the Earth Lab community struggle from some of the same issues that you were talking about in terms of finding and accessing data that's going to be relevant to the question that they're trying to answer. And so I was really excited to see how you're implementing some of the feedback from your community into your user tools. And I'm excited to share these resources with the folks that I get to work with on a day-to-day basis. So thanks, Madison.
Yeah, fantastic.
Elizabeth, do we want to get any other comments or feedback from anybody else
You
before
know,
I start?
I think let's just go ahead. It's going to be a fast day, so let's go ahead. You got the mic, and do a formal introduction, okay? Of Nathan Carter. Did I say your last name correctly? Tell me how to say it.
Yeah, you got it exactly right, Elizabeth. Thank you so much. It's a challenge.
Okay, no, I love it. All right, Nathan Carter is the Education Director at Earth Lab and ESOL at the University of Colorado Boulder, where he focuses on building capacity to teach and learn environmental data science, particularly at minority serving institutions. And so, with that, again, Nate, I will give you a 5-minute and 1-minute warning. So, let's get started.
Perfect. Thank you so much, Elizabeth, and thanks to the ESIP community for bringing us in here today. Can you all see my screen? I think I'm sharing now, picture of my face there. If I change the screen, can you see like a white slide now that's got description of ESOL on there?
Yes.
Okay, perfect. So like Elizabeth said, I'm the education director at Earth Lab and the Environmental Data Science Innovation and Inclusion Lab, which abbreviated to ESOL. We are an NSF-funded data science synthesis center. We've kind of got 4 big pillars at ESOL that really kind of define what we do, including, transformative science across Earth scales. We have a cyber infrastructure and data analytics team that's focused on building collaborative and scalable cyber infrastructure. We're really focused on building an inclusive community for environmental data science through programs like working groups and innovation summits, which I'll talk about more at the end. And then the piece that I'm going to talk about here this morning is the component that I'm in charge of, which is educating a diverse environmental data science core. And I'm going to focus specifically on a paid internship called the ESOL STARS program in the next 15 or 20 minutes or so. So you heard Elizabeth and me both mention this idea of environmental data science. We see environmental or earth data science or EDS as kind of living at the intersection of these sort of 5 grayish green globs. And so having some core disciplinary background in earth and environmental sciences is a key component of EDS, as well as having some core computational skills. You heard Madison talking about the need for developing skills with tools like Python, QGIS. We also value using a diversity of data types. And so looking at different structures like raster and vector data, looking at different data sources, so remotely sensed data from sensor networks here on Earth. We're also really focused on making our science open and reproducible when we can. Again, with this idea of helping to build capacity and democratizing access to these tools. And then finally, we're really focused on helping participants on our programs build out core communication and collaboration skills, or what we call super skills. So being able to work in interdisciplinary teams, across time zones is a critical piece of what we try to teach in our programs. Why do we need earth and environmental data science education? Well, like you just heard Madison talking about, there's like a ton of data out there, and folks just aren't always comfortable being able to work with those data, find those data, use those data to start answering questions. And so this slide here really just communicates really like the constellation of different data tools out there, many of which you're going to hear about today, and many of which some of you are probably already experts in. And so I won't go into a lot more explanation here other than to just say, again, there's a ton of data out there and we need folks who are able to work with that data that will be able to help them answer meaningful questions. The truth of the matter is, though, it's hard to develop those skills. You heard Madison talking about in her talk just a minute ago, feedback from the Unbound users. They struggle to develop the skills to work with these data. And you can go to some of these places and get a degree in data science or environmental data science, but the fact of the matter is a lot of these places are hard to get into, they're expensive, and that can make it difficult for a large chunk of the population to develop the skills needed to work with these different earth and environmental data. We think that that contributes then to a lack of diversity in the STEM workforce. And so we look at STEM degrees awarded in the US through 2020, we see that the majority of those are going to folks who identify as white. The majority of those go to folks who identify as male, so people who kind of look like me. And that's definitely true when you look at the engineering, physics, and computer and information sciences, where fewer than 25% of bachelor's degree are awarded to females. So with these ideas in mind, we have developed a couple of different training programs that I'm going to describe in some detail here, specifically the ESOL STARS program, which was modeled after its predecessor, the Earth Data Science Corps, which I'll mention very briefly towards the end. But both of these programs are really kind of built to do the same thing: tackle challenging earth and environmental issues, help contribute to diversity in the STEM workforce, build capacity to teach and learn environmental data science, particularly at smaller minority-serving institutions, and train the next generation of data scientists. And so let's talk about the ESOL STARS program specifically. You heard me mention that that was modeled after another NSF program, the Earth Data Science Corps, which you can read more about there. This is a paid internship for undergraduate students and faculty. The model is that we bring folks in kind of towards the end of the spring semester to do some virtual training. And then new this year, we'll be bringing people to Boulder to do a 2 or 3 day long kind of intensive boot camp. And then folks will go back to their home institutions and work on an applied project. In the previous 2 years, we've done all of this over Zoom. And so we're really excited to kind of try something new this year and bring people to campus to do some of this in person. You can see down there at the bottom some of our partner institutions. And so through years 1 and 2, we worked with Oglala Lakota College and United Tribes Technical College, which are tribal colleges and universities in South and North Dakota, respectively. We've also worked with a group of students and faculty from Metropolitan State University in Denver, which is a Hispanic serving institution. And then this year, we're super excited to add 2 more schools to our group: Haskell Indian Nations University in Lawrence, Kansas, and then San Carlos Apache College and Tohono O'odham Community College, which are both located in the outside of Phoenix and Arizona. And then through the first 2 years, we've brought in 24 undergraduate students. We've worked with 6 faculty, and we've had 12 what we call advanced interns, so students that we've brought back either from Earth Data Science Corps or from the first 2 cohorts of ESOL STARS to help those students continue to build out their data science toolkits. We do focus on helping build diversity into the environmental data science workforce, so we're really excited to share that. And this is all data, I should mention, that was just collected from our year 1 cohort. So not a huge sample size here, but the trends across year 2 are similar. About almost 3/4 identify as coming from a tribal community. Almost 3/4 identify as female. And then here's a snapshot or headshots of our first cohort of ESOL STARS interns and faculty. So you can see some of the folks that we're working with here. Really love working with this group. And then I've also got some information here about our kind of our curriculum, which I'll talk about in more detail in just a second. But we will share these slides out at the end so you can have access to all these things. But we use GitHub and GitHub Pages to build out a course syllabus. We share all of our notebooks and curriculum using a tool called GitHub Classroom so that we can easily distribute Jupyter notebooks and coding tools. And then we have an open Earth and Environmental Data Science textbook that lives at earthdatascience.org that's viewed by hundreds of thousands of global users each year that are interested in trying to learn these tools at their own pace. So the curriculum, what are we teaching in ESOL STARS? Well, we start out by having students work with data from NOAA's National Center for Environmental Information. And so we ask students to access NOAA's NCEI API and bring in climate and weather data to look at how trends in precipitation and temperature have changed over time. We start out with an example data looking at temperature in Rapid City, South Dakota, because that's where a lot of our students are from. And then we ask them to recreate that workflow for another place or time that's interesting to them. And so we've also got students up in Fargo, North Dakota. We have a student who had a kid that was going to school in Austin, Texas. And so she wanted to see what the precipitation trends were looking like down there. So this is some example of student work and a link to the data set that we're using to access that data. The next lesson, part of the ESOL STARS curriculum, asking students to access data from the USGS Water Data Program. And so looking at how flooding can impact local communities. We had a lot of folks living on the Pine Ridge Indian Reservation that was flooded back in 2019. And so they looked at that, and students get to talk about like how the flood impacted them. And so they're learning how to access this data, and they're also learning how to, I think, tell a story with the data that's going to be locally and culturally relevant to them. For the NASA folks out there, we are using some NASA data as part of our curriculum too. And so here's an example, of how we're working with some MODIS data to look at how vegetation health is changing over time. This particular example is looking at how vegetative health has improved after water rights were given back to the Tohono O'odham community back in, I think 10 or 15 years ago. And so this plot up here shows how the vegetative health has improved once this tribal community got water rights given back to them. And then here's some examples of other student work using some of this NASA NDVI data. So shout out to the NASA crew, thank you. I think we're using the Appears API maybe, and so students get another chance to do some programmatic data access, which is kind of nice. So we have this training that we do with ESOL STARS, and then we ask students and faculty to turn around and apply what they've learned to some locally or culturally relevant project. And so these are 3 examples from the year 1 cohort. We had a group of students from MSU in Denver that were interested in looking at water quality and quantity issues on the Dene Reservation after a mining incident that occurred upstream from them several years ago. We had a group from United Tribes in Bismarck, North Dakota that was interested in looking at relationships between precipitation and river discharge on the upper Mississippi River tributaries. This is this plot here. And then this one is so exciting. I love this project here. Students from Oglala Lakota College, which is on Pine Ridge and Cheyenne River Indian Reservation in South Dakota, we're interested in creating a habitat suitability model using soils data from Polaris and I think some land use cover from Landsat to figure out where historically and culturally relevant plant species would grow on different parts of South Dakota Indian reservations. And so really tying a lot of stuff together here in these projects. I know I'm running on time. I think I have about 9 minutes left, it looks like, Elizabeth. So I'm going to fly through these horizontal bar charts here and then hopefully have a little bit of time left over. The really exciting thing about all of this is that the folks that come into our internships generally don't have any background in coding or Python or in data science. And so here you can see, I love using horizontal bar plots. I noticed that Earth Data's new logo is a set of horizontal bar plots. I don't know that I had any, inspiration there. I doubt it, but I like things though. You'll see a lot of horizontal bar plots in these next few slides, but the story that they're telling is that, most of our interns come in, they're not comfortable doing any of this stuff with Python when they start our internship. And so you can see here, 9 out of the 14 students that answered this question were not comfortable using Python to work with time series data or work with spatial data in Python before they start our internship. And then you fast forward to the end of the summer and you ask them these questions again. And now you can see that they're starting to develop some moderate comfort with these different skills. Working with Python, particular libraries like Matplotlib to visualize data, those kind of things. Again, most folks aren't comfortable with that when they start, but when they leave, they're feeling like they can start to do these kind of things. So we're pretty excited about that. One minor detail I'll point out on this slide is that these people here who are somewhat, or even in some cases very comfortable doing these things at the start of the internship, These are the folks that took the internship the summer before and came back as advanced interns. And so we can start to see that the people that do this internship one summer after the next and get brought back, they come in with a higher level of comfort or confidence. And so we're having an impact there, and we're really excited about that. More kind of data science generally, so not specific to Python, but again, you heard me mention we're working with tools like GitHub and Jupyter Notebooks. Again, students not very confident working with those things when they start, and when they leave the internship, they feel like, okay, I can start to do this kind of stuff. So they're not learning all of Python in data science like over the summer, but they're getting a start so they can go and do more advanced stuff later on. In addition to those technical skills, we're also asking students about, do they feel like they belong to a community of scientists? Do they 5 minutes? Okay, perfect. Do they feel like they belong to a community? Do they identify as being a scientist? And we see that the needle is not moving as much here as it was on some of those other slides. But again, keep in mind, we're doing all of this over Zoom. It's hard. I think it's hard sometimes to build that sense of community when we're sitting at a computer looking at our little Brady Bunch screens. And so the fact that we're seeing any motion here at all, we think is exciting. We're also interested in students' ideas about working with earth and environmental data science as a career. And so do you see yourself as an environmental data scientist? Are you planning to work in earth and environmental data science? And here we see some interest in that as well. All that data that I just showed you was from the students, the undergraduate and advanced interns. We also do work with a lot of faculty as well. I apologize for all the text on this slide, but the big takeaway, some of the feedback from the faculty that we've worked with, they're really interested in trying to apply these skills to the other classes that they teach. They're interested in taking more classes to become more advanced in earth and environmental data science. And it's really it kind of reignited their interest in doing research and teaching with data. And so having an impact on the students, having an impact on the faculty, and we're pretty pumped about that. If you'd like to read more about what we're doing, I did just kind of go through the ESOL STARS program in some depth. You heard me mention that's modeled after the Earth Data Science Core. We did have a paper published in the Journal of Statistics and Data Science Education last year sometime. So if you want to read about that, there's plenty that you can learn more about there. There's a QR code for you. And then finally, if you want to join us, we would love to have you. So there's several ways for you to interact with ESOL. You just heard me mention ESOL STARS, which is one piece of a much larger puzzle. And so if you're a postdoc or you're about to be a postdoc or you have students who are about to be postdocs, we are going to be opening up the application for a third cohort of postdoctoral researchers sometime during the summer of 2025. So stay on top of that. And if you'd like more information about how to get added to the ESOL mailing list, we'd happily do that so that you can get details about postdocs. We also fund working groups. We've got 2 cohorts of working groups working right now. We will put the next call for working groups out later this year. If you'd like to learn more about working groups or propose a working group, we'd love to hear from you. We won't talk anymore about ESOL STARS. We are having an upcoming data short course this summer that's focused on anybody from novices to experts that are interested in learning how to work with tools like GitHub, Jupyter Notebooks, teach with these tools in your classrooms or in your research labs. And then the big one, which we're hoping we can get some folks from the ESIP community involved with, is our upcoming 2025 Innovation Summit. It looks like our topic this year is environmental tipping points and transformations. We'd like you to apply for that by the end of the month. So just another week or two. This event is held at the University of Colorado in Boulder. We do have funding to help folks who need it to get travel. Elizabeth has attended a couple of those in the past. I know she's had a great time. Don't think she can come this year. We'll miss you. But we'd love to get anybody else who's on the call here today or part of this broader community to come to the summit. And if you'd like to learn more about that, I'm happy to talk more. Last couple of things, if you'd like to see more about our curriculum, so the stuff that we teach with, we do make all of our teaching resources open. And so this QR code here will take you to our ESOL Learning portal, which is kind of a work in progress. But you can see here that we've got lessons to our Introduction to Earth Data Science textbook, which my partner Elsa Culler from Earth Lab is going to talk about in the later session later today. We've also got the curriculum for our STARS program, which I talked about, and our short course. We also do workshops. So we did a workshop for the folks in the Macrosystems Ecology for All group, or MIFA. as well as a workshop for some educators in Chicago late last fall. So you can see those lessons there. If you'd like to learn more about how to contribute to this, we'll be hosting sessions on how to do that coming up. I apologize for not having more information about that, but I've given you enough already, I think. And then just one more slide about the summit. Here's the QR code that will take you to more information about the summit specifically. Again, topics are tipping points and transformations, looking to explore big data, promote best practices and ethical open science, and support diverse and inclusive teams. I think that's it, Elizabeth. I might actually have like an extra minute left, which is kind of crazy, but just want to say thanks again. Elizabeth, do you want to say anything about our Innovation Summit?
I love the Innovation Summit, and the pre-work and the workshops before getting on site really does address building capacity for those new users. And we don't have a lot of time. However, I did want to, so I want you to check, Nate, the Padlet. There was a question from Abner that asked, curious about the decision process was like for incorporating the use of Python in the curriculum instead of other languages like R. Thought that you might want to speak on that, and then we'll have to move over to the next presentation.
Great question, Abner. I will say that when we originally started our environmental data science certificate program, which Elsa is going to talk more about this afternoon, we did teach that program using R, and we do have lessons on our earthdatascience.org webpage that is kind of a parallel to some of the stuff that we teach using Python. I think, and this is kind of before I came here in 2020, so I don't want to like totally throw my predecessors under the bus, but I think the reason that they shifted away from R and into Python was that we did a survey of users in the community and in the industry, and asked folks like, what are you looking for in terms of skills from folks that are freshly graduated or entering the workforce. And it was kind of by and large, folks were more interested in having folks with Python skills than with R. And so that, I think, weighed into that decision. That could be that we were asking, maybe a lot of, GIS technicians or folks that work in geography. I know that like ecologists, really like using R, and there's a lot of other community members that like R as well. But Abner, from my understanding, that decision to kind of shift more towards Python was driven by results from market research and industry research.
Thank you, Nate. You're a rock star. Thank
Thank
you so
you.
much. Thank you, my friend. All right, so now we're going to move over to the next presentation, and this also includes Nate. Is Elsa on the line as well? Do you know?
I don't see her here yet. I think she's going to be here in about 8 minutes.
Okay, all right. So we're going to kick this off. We're adding to this University of Colorado Boulder mix. We're adding Erin here, and so I'm going to do some introductions to Erin as well as Elsa, and hopefully she'll drop on soon. So Erin Fries is the newly appointed ESIP Technical Community Manager. He is a seasoned geospatial professional with a passion for advancing open and collaborative science. He brings over a decade of experience working with NASA's Land Processes Distributed Active Archives Center, also known as LPDAC, where he played a key role in facilitating data access and community engagement. Prior to his tenure at NASA, Erin worked as a contract research geographer at USGS EROS. ERIS. So we also add Elsa Kohler is the instructor and curriculum developer for Earth Lab and ESOL at the University of Colorado Boulder. She teaches CU's Earth Analytics Foundations Professional Graduate Certificate Program and develops environmental data science curriculum for researchers and practitioners at all levels. And we are going to go ahead and turn this over. I believe Erin is going to kick us off. And Erin, would you like me to drive this screen share, or would you like to share?
Feel free to drive.
Okay.
Yeah, so I'll kind of kick things off. I was fortunate enough in my previous position to partake in this activity we called Higher Sense. And I'm bringing you today just kind of my personal perspective. Actually, I mean, within the group that had gone from the LPDAC, our perspective on what we got out of this meeting. And so go ahead to the next slide. I got a pretty bare bones presentation here. Higher Sense is the hyperspectral thermal remote sensing and environmental justice workshop. This is a joint activity between NASA SBG, or SBG being surface biology and geology, and ESOL. This was an in-person workshop over 4 days in June at the University of Colorado. Next slide. This was aimed primarily at geospatial professionals, undergraduates, graduate faculty members, primarily at tribal schools, tribal colleges. And the intent was to just gain hands-on experience with thermal data and hyperspectral. And given that we have some of these, NASA has some of these precursor missions to SBG, where we have a thermal sensor and a hyperspectral sensor on the space station, it was a great opportunity to start introducing these technologies to different groups and see how they could be leveraged. Next slide. The planning and kind of execution, of course, it was split into, I split them into kind of 3 phases. The pre-workshop, from a faculty or a facilitator standpoint, of course, we met multiple times to kind of bounce around ideas for tutorials and applications to highlight with these data. It's all relatively new data, so it was just a challenge, really, to get things the data to match and work together, identify kind of intersecting data that we could use specifically in the Colorado region that we were focused on. All of our facilitators went through a cultural awareness training, which was something I had never gone through before, but I'm super glad we did it. It definitely kind of opened my eyes to a lot of things that would have probably tripped me up had I gone without it. The participants took part in multiple kind of virtual workshops where they did some kind of capacity building in GitHub, getting familiar with Python and Jupyter Notebooks, and then getting familiar with this work environment that was made available to everyone, this ESOL Cyberse Cloud. As many of you know, that work environment can be a challenge, and there's multiple strategies for kind of getting around that, having these shared environments that people can just log into, and we have a shared set environment that everybody can just get going in. So just getting people introduced to that space was part of the kind of pre-workshop activities, and then also kind of what to expect when we got to Boulder across both the facilitators and the participants. Next, please. The in-person event kind of had 2 parts to it. We had the classroom part where we had panels for connecting tribal communities and EJ and data science. We had authoritative kind of presentations from mission leaders for EcoStress and EMIT. And then also kind of overall NASA SBG kind of presentations about how those applications and the planning is going with those missions. And then we had a number of hands-on tutorials. These were kind of ranged from just kind of getting started, specifically in Python in this case, finding data, where it's located, accessing the data, and then working with it in one of a handful of applications that we identified, specifically invasive species, forest fire, and a couple others. There was also an opportunity to do some field work. The participants were able to use the NASA Stella instrument, which is kind of I don't know if cheap is the right way of using it. It's a little bit more accessible than a actual field spectrometer, but it's a very useful and very great for education anyway, where they were able to use these stela, take some spectral measurements just around, I believe, the facility, and come back, upload that data, and see kind of the spectra that they had recorded. And then we had on the last day a field trip where we went to the Mountain Research Station. We brought out the big guns, the field spectrometer, and learned kind of the protocols around taking those observations and making sure that they were scientifically accurate, and just kind of exploring there. And so that was a really cool experience, I think, for all. Next. Nate mentioned the ESOL workshops or the working groups, and I believe that this group had kind of self-assembled and created one. And so I think the working group is the two that are active is one that came out of this higher sense group. And ideally, this group is going to, or is trying to bring together the tribal members, scientists, students, NASA remote sensing researchers, and come up with some methods to identify, monitor, and address environmental justice at tribal communities. And so I have not been participating in this group, but it's a nice kind of after activity that continues to go on now. And maybe Nate would be able to talk a little bit more toward that a little bit later, maybe. Let's keep going. All right, and so this is kind of where we get into my personal opinions, and some of these will be maybe like duh, but previous to this workshop, I had not experienced anything like it really, and I had done and hosted numerous workshops before this. And so kind of getting right into it, tribal diversity is a thing, like going into an activity and just assuming that everybody there is on the same page and has had the same experiences is a mistake. And you'll find out quick when you're dealing with these tribal communities. And so one important thing here is to, at the beginning of your workshop, do introductions. And when you're planning your workshop, plan for introductions that are very, very long. And so the introductions we did not do initially, and we were called out midway through the workshop that we didn't do this. And it is actually kind of a sign of disrespect to these tribal individuals. And so it's a great way to learn and hear where the participants are coming from. We had a cultural advisor that was able to give us, try to be aware of the words that are using and give us some guidance there. And that's an invaluable resource when working with tribal groups, trying to understand the cultural differences and handling any sort of discourse. Now, none of it's mean-hearted, right? There's gonna be differences of opinions, differences in perspective, and it's just things that you need to kind of approach head on and discuss and be aware of where everyone is coming from. Next slide, please. It is important to understand the group that you'll be working with, the participants of your workshop. So, you don't need to have a PhD in the history of the specific tribe or tribes that you'll be working with, but having an understanding of their background is very important. And then also work with those groups to understand the issues that they're having. So often, at least where I came from, is we would create these or come up with these interesting agricultural application examples or urban heat island examples, and they're just not terribly applicable. What these groups are interested in are stuff that are impacting them, and they know the problems they're trying to solve, and they know the barriers that they're running into. So consulting with them prior to the workshop is the best way to make it the most beneficial workshop and experience for the participants of that workshop. Next. Get comfortable being uncomfortable. I love this actual phrase because it came up a number of times, and like I said, nobody's there to tear anybody down, but they have a completely different experience. And I'll kind of give an example of when I got up and was doing a presentation, I was asked who I represent. And at the time, I was a contractor for USGS, but I was presenting, and my core job function was to be an advocate for NASA, specifically ESDIS and the data archives that we manage. And I was like, for all intents and purposes, I'm representing NASA. And he's like, no, you are USGS. And they had a history, not a good one, with USGS. And he's like, we need to know who we are being involved in. They need to have all the cards shown up front before they start to trust you. That bridge needs to be built, and it's built little by little. And it's very easy to kind of get broken down. So understand their needs, their concerns, be open to what they're communicating, and talk it through with them.
5 minutes.
Okay. Again, the participants know their gaps. They know what limitations they have right now. And so coming in and just saying, use Python, use this advanced technology and infrastructure, may be a miss. We had to make a pivot midway through because we had a number of Python activities, and we noticed that we were getting less engagement. We heard often in some of our pre-workshop stuff that ArcGIS is the language of the tribal communities, specifically when it comes to geospatial work. And so we were able to pivot some to an ArcGIS workflow or an example, which kind of got more engagement and kind of brought back the crowd. And so being kind of flexible and able to do some of that stuff is important. And I think actually the EGIS stuff would be fantastic to be able to bring to these communities and highlight NASA data there. Next one. Finally, this is kind of the after the workshop. You're building a relationship here. It's nothing's guaranteed here. You are trying to establish trust, and it's very easy to lose given our current situations. And so being dedicated, if you're going to make a commitment, make the commitment, and you need to just demonstrate that you're going to be a reliable partner and able to help them and be partners in whatever endeavor they're looking for. And so I'd encourage anybody to really think whether you would be able to support such an activity. And if you are, awesome. I mean, put your heart into it. And if you have reservations, be upfront and tell them that we can contribute this way. This is how we can be usable to you. And so I think that's all I have for this slide. So.
All right. I think we have a couple of minutes. Yes, I think that's it.
Awesome. Okay.
All right. Do we have any questions? I see here that Nate has put some links to the HigherSense GitHub. I also put in the Stella link from Landsat. So do we have any specific questions? Sounds like a pretty vulnerable experience, Aaron.
It was. I had a number of discussions with the facilitators where it was like, was this a success? Like, and I'm like, your idea of success needs to change a little bit in that type of environment. Like we are establishing a relationship. We're creating trust. Whether they completely uptake a tutorial and take it home and start to use it, that's great. But we want to establish a relationship so that we can continue to work together to improve, all aspects of NASA data and using within these communities.
Thank you so much for sharing that. Those are really personal stories. And it's where I feel like we learn a lot as professionals when we get outside of our comfort zone. So I really appreciate the ESOL team and the university for providing those opportunities there. I see that our time is up for this particular session, or this particular presentation. We're going to go to the next presenter, which is myself and Aaron again. But I did want to encourage us to go to that Padlet. Put in your questions. We do have a couple of driving questions that might be relevant to your questions about engaging potential users that exist. What kinds of things do we need to think about in terms of being vulnerable and being explicit about what we can offer and what we don't have the capacity for? Like how do those play out in terms of our planning and execution of new collaborations? So put your thoughts in there if that feels comfortable for you. I am going to now. All right, so now we're going to tee up a different kind of outreach data engagement event, and this is through NASA's Space Apps Challenge. And so this is something I had the opportunity to work with Aaron on, and so we're going to talk to you about the good, the bad, the ugly, and give some reflections on that, which is a very successful program. So we're going to be reflecting on the 2024 challenge. We're going to talk specifically about one of the two challenges that we both helped with, but this one was focused on agriculture, and we'll talk about those lessons learned. So what is a Space Apps Challenge? It is the largest annual global hackathon that engages NASA and space agency partners to our free and open data to address real-world problems of Earth and space. And who can participate? We have, sorry, I'm missing my cues here. Let me just go ahead and tee those up. I think I got one more. All right. Who can participate? Everyone. This includes coders, scientists, designers, storytellers, business folks, makers, builders, technologists, no matter what their background, age, or skill, they're invited to participate. When it took place in October, 5th and 6th, over a weekend, and it occurs virtually as well as in these in-person events around the world. And so in terms of how it's executed, these challenges are drafted and submitted by NASA subject matter experts. And so this particular one, we worked with NASA ACRES, which is the NASA Domestic Consortium for Agriculture through Earth Action, formerly Applied Sciences. And we crafted this challenge event. And then groups around the world, they build their teams and they pick a challenge. And so, and then once that's in place, then over that weekend, we help guide them. And then after it's over, we evaluate the projects. And then in terms of why is this important? It raises awareness of open data. It inspires creativity and collaboration, and it nurtures an interest in STEM within the next generation. And so in terms of the 2024 Space Apps by the numbers, they limited it this year to only 20 challenges. And so we had two, one, this agriculture one, and another one we worked with Landsat on. There were over 93,000 participants, over 15,000 teams, There were nearly 10,000 projects submitted over almost 500 locations, 163 countries. I mean, you guys can read this, but I mean, 15 space agencies. I mean, it's just a lot, right? This is like so many wheels, spinning, but it was a blast. And so in terms of, okay, so like, what are the expectations of this? Keep in mind, these folks that some are considered data scientists, app developers, that may have a background in that, and then some just did not at all. And they only had 2 days to work on their projects and complete it. And they were not expected to create working prototypes. And if they did, we were unable to like verify their code or download their apps. I mean, so we tinkered around with it as much as we could. We analyzed it, and the judging criteria were impact, creativity, validity, relevance, and presentation. And so its impact is how much impact, quality, and quantity does this project have? Does it solve a big problem or a little one? Creativity was more about how innovative is this approach? Is it novel or something that hasn't been attempted before? Or is it incremental improvements to something that already exists? The validity is the solution. Is it scientifically valid? And will it do what it's set out to do? Which is kind of hard to measure in some cases. Relevance is this project responsive to the challenge for which it's submitted? And then presentation, how well did the team communicate their project? And so our particular challenge, and excuse this ridiculous video here, but we had over 1,000 projects submitted to this one challenge. And those were reduced to 90 after being screened by the Space Apps Challenge team, which we're very glad that they did. But this is like really ridiculous. So with we worked a variety of folks from NASA Acres in producing this video, and so it was kind of fun. And so next, I wanted to mention that we had I received this email from Kara Crosby that said that it was received the highest number of global nominees in Space Apps history, which is pretty awesome. And so, all right. And we did have 2 award winners, which was pretty incredible. And I will be sure, if I've not already done this, I will put these 2 links in the Padlet for you to explore. And now I would like to tap into my buddy Aaron to talk a little bit more about the more technical aspects of this.
Yeah, so I don't know if this is the first time or they have been doing GitHub. This was my first actual kind of firsthand participation in Space Apps, and overall, I enjoyed the experience and the innovation that came from these groups. Space Apps itself used GitHub kind of as the organization structure. It allowed the project teams to kind of be built out there, and for them to join and connect with each other. The Space Apps kind of group proper was very organized within that space, I believe they were using a project where they were using labels to assign the specific questions to the specific kind of SMEs or the subject matter experts. And overall, it was very smooth, I guess. From my perspective, for our team, I believe it was a very smooth experience where, as a GitHub issue that was linked to our label came in, we were able to address those questions as they came in. So I think that's probably all I want to say about that. Lessons learned. So these, I mean, come across relatively negative, but it's really kind of constructive, right? I mean, these are things that we think would maybe help improve the experience, specifically from a judge's standpoint, but also from just a user experience. And so this first one I have on here, was an experience I had as the subject matter expert. I was kind of monitoring the Appear system that is hosted within NASA Earth Data, and also the USGS AROS Earth Explorer, where Landsat data is accessible. And these hosted tools and services, this is a weekend project, and having just 90 or more projects come in and hammer these systems can be problematic sometimes. And so there needs to be, I think, better communication that, hey, this event is going to be happening on the weekend. We expect there to be a lot of traffic. Is there any planning we can do? Is there anyone you can have on hand that can answer any kind of troubleshooting questions or address the system if we have a problem? We had several problems on both systems, which I think kind of made the experience at least not optimal. And so it would be nice just to be kind of on the same page with the system and service managers. Include more user-centric design elements. Some of these are some of the ideas, and you'll get into this a little bit later in the AI ideas, but some of them just don't have an actionable user-centric kind of a use case, application. And so the idea that those would be kind of selected and picked up, is not great. And so that's more of a, if you are participating in a space apps, make it as close to real world application as you can. There's a lot of kind of teaching or best practices that can be passed along, things like citing your data properly, identifying data quality issues, how to work with data quality flags in different layers, the impact of resolution and whether that resolution is proper for your analysis, using AI, using the latest, greatest technology. There's a lot of those people trying to do something like that, and they just don't really stand out because they're very difficult to implement in a 2-day hack week or hack weekend. And we're really looking for something that is actionable, and it's something that we could be like, consult with agricultural specialists or farmers and be like, is this useful? Would this be something that you would adopt? So getting back to that user-centric design. What else we got? Yeah, we were one of the most popular projects, and we were a team of, what were we, 4, 5? 5.
5.
And judging based on that criteria that Elizabeth had, which was also fairly vague, and getting to a project that was kind of showed that it was above the others, I guess, was a difficult task for us. So Earth science is popular. Make sure that you have the capacity to support a hack weekend, and then the judging that follows. And then overall, I think from the Space Apps project implementation, having documentation and communication, tightening up some of that is important. We use Slack. I don't know what other projects use, but it was very nice to have an open Slack channel where as we broke up kind of the monitoring of the GitHub issues being submitted, and had somebody on our team monitoring that. As a question came in, we'd ping Slack for the person who was probably most useful in that answering that question. And so it was a great, of course, I don't think this is a strange topic, but Slack was very useful in that communication and getting the answers to the questions that were being submitted. That's it, I believe.
That is
But
it.
overall, of course, it seems fairly negative. It really is a very well run, I think, and very interesting opportunity to participate in.
Yes, and I would recommend that if you are interested in partnering and presenting a challenge idea and helping to kind of scope out some of these things that Aaron mentioned as speed bumps, please reach out. They do it every year, and we'd love for to collaborate with others and bring some novel ideas to the plate. With that being said, let's go. Thank you, Aaron, so much.
Mhm.
So now we have about 6 minutes left for you to respond. Think about what you've learned today. Please drop it into the Padlet. This is any questions that you might have or follow up. So if you've heard something, let's say from Aaron or Nate or Maddie, that you want to maybe schedule some office hours and see how you can learn more or apply to those internships or whatnot. This is a great tool for that. And there's my time. Okay. So this time is yours. And also feel free as you are reflecting into the Padlet. And if you don't mind, Joe, if you'll put that Padlet back in there. Thanks, Denise. What questions do you have for any of our speakers? We can go ahead and open it up. We have 5 minutes. Thank you, Joe. I did want to mention that Elsa was having trouble logging into the system, so we're sorry that she couldn't join us. Kelsey, I see your hand up.
Yeah, hi, thank you for this presentation. It was really interesting, and this is something that is an interest of mine, but not something that I had a ton of background in. So I just recently finished a PhD at the University of Virginia, and something that I noted after finishing that and getting more into data management and data use kind of culture, I've been thinking about ways to, I guess, advertise or connect users with the data. So one of the things that I posted on the Padlet was that there is just a ton of data waiting to be examined, a ton of questions that can be answered with the data. And there are also a lot of researchers available in the form of, grad students and doctoral students, even beyond, I guess, applying for, to do it, to analyze those data through EASL. And then Madison replied that the expo booths that they do at things like conferences are very valuable because it leads people to know about the data available. But I was wondering if there are any other sort of outreach efforts, like directly with universities, like someone reaching out to universities and talking with graduate student programs. I'm thinking, something like an environmental science department that I just came from. I'm just wondering if there is like an effort like that, and if not, or if so, would that be useful? And just sort of thinking about ways to sort of take the data to people rather than ask the people to come to it, even if it's, an expo booth. Does that make sense?
Mm-hmm.
Yes, who would like to address that?
I guess I can touch on it from a kind of NASA as this standpoint, as the kind of data distributors for NASA Earth data. I am fairly certain that each of the DACs have contact with close proximity universities. LPDAC has kind of frequently presents and demonstrates data use at South Dakota State University and the University of South Dakota. And we have almost like a farm system with those universities to bring them into the USGS and NASA LPDAC. I'm fairly certain that all the DACs have something similar, maybe not all of them, but pretty close. It is so hard to get across all of the DACs and do an in-person event or even a webinar. So it's a challenge that I don't know we've figured out. The only thing I can almost think of is creating kind of a web series or web like a YouTube series where each of the DACs maybe kind of talk about their data and what they have. And yeah, we do. It's always kind of jarring to hear stories that, oh, NASA has free data. We have all this Earth data observations from space. It's like, man, I spent 10 years LPDAC doing that type of, outreach, and it's hard to hear that sometimes, but it's reality because I hear it a lot. Yeah, that's kind of what I got to say on that matter.
Great, thank you.
I will say, Kelsey, that NASA Earth Data has a webinar series. We also have a presence at AGU and AMS and some of the big conferences. And we have started doing pre-conference workshops at a local university. In fact, we're working with NATE. We're going to be out in Denver for the Commodity Classic. We're working with NATE at the University of Colorado to go do an in-person workshop at Metropolitan University of Denver. Yay! All right. So we're trying, right? And so that's exciting.
And I think if you would know of anybody who would be interested in having maybe a workshop or being part of a curriculum of any sort, reach out to those. I mean, Earth Data, or if you have a contact to a specific DAC, reach out to them. I don't think they would turn it down.
Okay, it's something that I will continue to think about, but I see that it is sort of a gap, and not due to lack of effort, but just something that I can hopefully contribute to the long-term solution. So I'll keep it in mind. Thank you so much for the thoughtful responses.
Thank you, Kelsey. All right, so we're 1 minute over. Thank you so much to our presenters. We'll see you back here, I believe, around 1:10, I think, to get on the tool and enjoy your lunch. Stand up, take a walk if it's not snowy outside. And yeah.
I'll kind of make an announcement too. The research showcase later today is at 4 Eastern. So make sure stay on and kind of participate in that, please.
Thank you all. Welcome back, everyone. Thank you to the 8 people who were back, and hopefully you had a nice lunch or breakfast or wherever you are joining us. I want to welcome you to part 2 of the Data Democracy Sessions, empowering everyone with our data tools and services. Again, I just want to say that one of the many reasons why I love ESIP is the core value of inclusiveness, and that comes with collaboration, which is why we're here today. It is important to note that discussing governmental policy or personal opinions about such things are not in the scope of today's session, but anyone discussing these ideas will be reminded of this policy. So let's kick off this session to learn about current Earth science data models of excellence for democratizing data for all, as they show us the examples of how they embed inclusivity and collaboration in their work. So hopefully you can see my screen. So let's go ahead and kick this off. There were some minor adjustments to the schedule today. So I wanted to tell you that sadly, finally, the Earth Lab group from UC Boulder had a technical issue, and so we're going to pad some time for Kit to talk about the school program. We'll also use some of that time for question and answer, which is quite nice because the other sessions really haven't had a lot of question and answer time. And so that is there. So here's the lineup for today. Also wanted to mention that the Climate Match Academy, Jenna Pearson will be presenting via video. She provided that last week, so she will not be here in person, but we've got her contact information. And then, so let me go to the next slide. Give me 1 second as I adjust. So want to also remind us of the driving questions for this session. What are the needs that our non-super users have for accessing and making action of our data? What current models are used to address these needs to help users access and use our data? What communities of potential users exist that we really want to engage, and how might we do that? And then finally, how do we work together to leverage some of these awesome resources and assets to support these new users? So those are the guiding questions. I do want to highlight for us the Padlet that I created for us today. Here is the QR code, and I will also put into the chat that link. And so wanted to highlight for you where these materials are. If you've not done so already, if you would please add your name to this list here with all of the various information. We also have the Padlet and the Mentimeter, which I will add in the chat. So let me get those. Thank you, Kelsey. I just saw your comment. You rock. So if we could open, thank you, Nicole, for adding your information. That's awesome. And I do want to say that we don't have any formal breaks over the next hour and a half. So you do you. Take care of yourself. Take a break when you need it. We also will have time for you to turn your microphone on. Please use the chat. Also, the Padlet. So I'm going to go ahead and add. I don't like this disappearing thing. Okay, so I've got my buzzers going off. So here is the Padlet tool. I love how Kelsey and Lindsay and others used it today in the former session, but I just want to orient you to this. So we've got the Sketch here. We've got that Google Doc where you're putting your name. We also have the Mentimeter survey. We'll be sharing that at the end and providing some feedback to this session. Those 4 driving questions are here. So as new ideas pop up that are centered around those driving questions, add your comments there. We also have a section just for the presenters today. And so feel free to add comments to Kit's presentation. Again, sadly, Earth Lab will not be here, so that will be taken off. And then at the end, we're going to be breaking out into 5 breakout rooms. And so those, depending on the numbers, they may be quite small, but I think that's perfectly fine. And you will put your comments into the various box depending on which room you get randomly assigned to. And so Megan's going to help with that. All right, so with that being said, all right, this is our Padlet, which has been shared, and I will ask that the fellow, if you don't mind sharing and resharing as people come into the room, these Padlet links and whatnot, that would be great. And then let's start give me 1 second as I pull my various screens over. And give me 1 second. So sorry. And we're going to kick it over to Kit. So at this time, let me introduce Kit. Kate McManus is from Columbia University. He is the primary investigator of the NASA ROSES Science Core Heuristics for Open Science Outcomes in Learning, also known as School Project. He is the applied science lead for the Environmental Flow Physics Lab at Columbia. So with that, I will stop sharing my screen and turn it over to Kit.
Hide these Zoom controls, and I think we should be good. Can you see me?
I can. Thank you.
Awesome. Well, thanks for that kind introduction, Elizabeth. As Elizabeth said, my name is Kit McManus, and I'm from Columbia University, where, just as of this month, I've taken on a role as the applied science lead in the university's School of Engineering and Applied Scientists and Environmental Flow Physics Lab. In my prior life, actually the past 18 years of my life, I was working for another research group on campus that many of you might be familiar with, called CEASIN. It's the Center for Integrated Earth Systems Information. And, one of the major projects that CEASIN operated is the NASA Socioeconomic Data and Applications Center, or NASA CDAP. So one of the 12 DACs throughout the country. I've certainly spent a lot of time in the past almost 2 decades supporting CDAC, whether that was building global data sets that integrate socioeconomic information with remote sensing, or instead building tools and services for people on the front end to use to help support their decision making. So today I'm here to talk about the School Project, which has a long name but a good acronym, and we only really ever call it the School Project, and no one remembers the acronym. But so I think that over time I've found that it's useful in these presentations to start out by talking about how the NASA Transform to Open Science mission conceives of open science. I find that we might have different definitions. So this diagram here, it sums it up really nicely. That open science is science that's accessible, inclusive, and reproducible. So it's not just that open means you can find it on the internet and download it, although that's nice. In the FAIR principles, findability is at the front. Accessibility, it means something more than that. It means that when you do locate some scientific finding, that it is presented in a way that makes sense to you. So, if we look across to all of the various communities that, taxpayer dollars that are contributing to federal research, it's really our responsibility to provide results to that in a way that makes sense to people. When we're able to do that, it creates some really good downstream effects. For the researcher, it's good for them because they're going to get more citations. Their research, ultimately, the more people have eyes on it, the bigger the impact. In terms of reproducibility, if we want to call something science, in science, you have to be able to reproduce results. So, how do you reproduce results if you're not being open about what you've done? So that transparency makes it possible for someone to reproduce the results. So I think that, this idea that open science is going to unearth a lot of hidden knowledge, and it's going to help us to solve some of the wicked problems that we're facing as a species. Things like climate change, that we need more people, more hands, more eyes, more brains, and diverse experiences to participate so we can accelerate scientific discovery. So I borrowed this slide from Shel Gentman, who's leading the Transform to Open Science initiative, or one of the leaders of it. And I think really this is the undercurrent behind TOPS, right? Is that we have some hard problems we need to solve, and we need everyone on board to try to help, because
although the nice thing about being a specialist is that there are certain problems we've seen a million times and we can solve them really quickly. The downside of being a specialist is you can get yourself kind of in a box where you can't see disruptive ideas that maybe a new set of eyes or a different perspective could provide that really will, accelerate scientific discovery. So I love this slide, and that's why I borrowed it. So I thought we would just take a second to think about, what does open science mean to you? And I don't want to create any barriers for folks to answer this question. So there's a number of ways you could respond. Feel free to respond in the chat, or if you feel comfortable with it, feel free to come off mute and weigh in on what open science means to you. So, in one of my lives, I'm a lecturer and I teach GIS at Columbia, and I know that sometimes you ask a question and there's silence in the room, and one of the hardest things to do is just wait. But over the years, I've gotten pretty good at it. So I'll wait until some brave soul wants to come off mute and tell me what open science means to them.
I can't find the control to raise my hand, so sorry. But I came off mute. This is Carla McAuliffe. I am the ESIP chair of the Education Committee, and my focus is in K-12 education. So for me, open science is the accessibility for any average citizen, which includes the K-12 population, to be able to access data freely, not have barriers to download it, visualize it, whatever.
Thank you. I think that's a great point, Carla, that it's not just adults that we're aiming for here. We're really, it's the entire citizenry. When we're opening up science, we're having impacts at, in K through 12, not just beyond that. Is there anyone else who would like to offer some thoughts?
Inger put something in the chat, Kit.
Oh, thank you. Yeah, so Inger, it's accessible, and another key word there is interoperable. It's interesting, this freely accessible without a user registration or a login, which I know is something that we've been debating for a long time. So thank you, Nicole. And I think also this idea about metadata, right? Like, this is one of the first things that I teach new GIS students is like, we look at metadata like the label on a V8 bottle. And, one of the things that's on the label is the expiration date, right? Or, what is it made out of? I think like without that appropriate metadata, not only is it not reusable, it may not be usable to begin with.
Hi,
Right,
Kit. This is Jenny Hewson. How are you?
Hey, Jenny. Good to hear from you. How are you?
Good. So for me, open science means that, well, a couple of things. All users can access the data with the minimal amount of hardware and software, and that it is both readily understandable and trustable. I think those are kind of key criteria for me.
Yeah, that's a great point. I found this type of issue in some of the courses I've teach where, maybe, a student, some students, they'll have a netbook or a very low powered computer, and, although they can go to a website where they could maybe download Landsat imagery, they just don't have the computing power to do it. So I think that's an interesting caveat on open, is that it means that actually, regardless of, what you're coming into the room with in terms of hardware or software, you should still be able to access and get some value out of this, taxpayer funded data.
Right. Thank you.
Thanks, Jenny. So I'll do a last call if anyone else wants to add a comment. Okay, thank you, Kelsey. I see in the chat that we highlight the importance of cloud computing. This is kind of building on what Jenny was saying. And I think that, we're in the right session, because this is a great segue actually for me to start talking about what the school project aims to do. So the school project it's quite ambitious, right? So it's one of the TOPS NASA Roses Awards, or TOPS Training Awards. And it's the one that's focused on NASA Earth science applications. So we're looking actually across all 7 of the Earth science themes that NASA has defined, water resources, health and air quality, environmental justice, disasters, wildfires, agriculture, and climate. Within all of those, I mentioned in my introduction that I spent most of my career working for the Socioeconomic Data and Applications Center. So I think in the school project, we've taken steps to incorporate socioeconomic information amongst each of these different themes. What the project does is, we demonstrate the data science life cycle, picking up NASA and non-NASA data sets, whether they originate in a cloud-based service or whether they're something that the user needs to download, and then demonstrating the life cycle through use cases around each one of these themes. So the deliverables of that are really online learning modules with interactive code. So this takes the form of Jupyter notebooks and Quarto notebooks. So Quarto is very useful if you're using the R programming language. So just again, for us all to be coming from the same place, this is how the project thinks about the data science lifecycle. So we start with either generation or collection. So we have many of our lessons are about obtaining data from existing sources, but we do have some lessons also that are generating new data, maybe through spatializing a spreadsheet, or even using an instrument like a drone with an optical sensor to do a damage assessment. The second step then is processing and storage. And this has a lot of implications for these cloud-based considerations, right? Like if we're gonna integrate data and we need to store it, are we going to store all the intermediate data? Maybe there's a cost associated with that if we're doing it in the cloud. Maybe there's some data that is just private. It can't be in a public cloud, and we need to access it locally instead, or store it locally. So we examine those types of issues. Then the next step is management and analysis. So, it's great that metadata came up. So, one of the things we talk about, especially in these lessons where we're generating new data, is, the importance of creating good metadata that's, both human readable and machine readable. The analysis, a lot of times that's like the part people are attracted to, right? Like they want to get some data because they want to do some analysis. So we spend time talking about statistical techniques as well as, other spatial analysis techniques, things like zonal statistics or reclassifying raster data, those types of things. In the fourth step in the life cycle is visualization and interpretation. So, here we focus on making charts and maps, focusing the learner on thought questions that help with the interpretation by appealing to examples from other similar work. And, one thing when I'm teaching new students about this, I say, sometimes you get to visualization and interpretation, and all of a sudden you come up with a bunch of new questions that you weren't thinking of, and you go back to square one, you're collecting more data. I think for new students, sometimes they get discouraged when they have to do that. But, as many of us in the room are well aware, it's part and parcel of doing data science, is that it's an iterative thing. And once you interpret, it often brings up new questions. Then finally, the last step in the life cycle is about open science and community engagement. So what we're trying to teach folks is, when they're finished, how can they send a link out to their grandmother, right? Or, share it with other colleagues and become part of a community. So this is how we conceive of the data science life cycle through these 5 different steps. And then in each of our lessons, we cover either one or more of these steps. So I think the thing that's special about this project is that there is a lot of thematic depth, because we have all 7 of these earth science themes. It allowed for a lot of variation and a wide breadth of different types of case studies that we could incorporate. Over here on the left-hand side of the slide, we're just mentioning a number of the open tools that we're relying on, like ORCID, Zenodo, Jupyter Books. I'll come back to that a little later. So let me tell you about, some of this work is still in process, but we have made progress on some of the themes already. So in October of 2023, we kicked off our water resources module in accordance with the NSF iGuide program. So I thought right out of the gates on this project, which it started in July of 2023, we had an opportunity to do some real open science where we're holding a NASA workshop inside of an NSF workshop, which I think is kind of novel. Here we heard from subject matter experts in water resources, and then with the audience, we brainstormed potential use cases that we would use in our lessons. That the audience consisted of educators, students, and professionals. So what this resulted in is a series of lessons, one of which I'm showing here. Here we're looking at in the map on the bottom right, we're looking at monthly data on precipitation anomalies in California. So the redder it is means the drier it is. So these are areas that we're experiencing in drought in January versus you see in March and April, it got a bit wetter. Then May is back to drought conditions. So this is part of our lesson 1 here, which leverages a NASA CDAC data set called WSIM-GLDAS, or the Water Security Indicator Model and Global Land Data Assimilation. What it does is what I just described. We explore water anomalies using a historic data. This data set, it stretches back to the 1940s. And it looks at heightened precipitation as well as drought conditions. So lesson 1 is this historic context. And then in lesson 2, we say, okay, well, what's going on right now? And with the help of our team, and including Jenny, who's in the room here, we use some data from MODIS that's distributed through Lance on near real-time flood information. And the lesson teaches people how to get their API key in order to access the latest data, and then to look at the analysis of recent water anomalies. Then kind of the next step is to look at the history and the recent and have some thought questions about that. In lesson 3 here, we're looking at lead in New York State schools. So lead in water has been a big issue, especially in the wake of the disaster in Flint, Michigan a couple of years ago. So as I mentioned, although we're looking at water resources, things like environmental justice and socioeconomic data, we've incorporated throughout the different modules. In April of 2024, we kicked off our health and air quality module at the AAG's annual meeting. And it followed much the same format. We recruited some subject matter experts from academia and professional ventures, They talked about the research that they were doing, and then with the audience, we brainstormed use cases for what we would utilize in the lessons. So what came out of that then is we have a lesson 1 where we're looking at air quality as compared to social vulnerability, focused in particular on the Metro Detroit area. In our lesson 2, we utilized the EPA's EJ Screen tool to examine environmental justice and demographic data, and then again, drawing the link back to air quality. And then in lesson 3, we looking at a different scale. We've looked at, in lesson 1, we looked at this localized scale, whereas in lesson 3, we're looking, okay, what is the state of things globally when you compare PM 2.5 and social vulnerability. We also used a proxy for health impacts in a CDAC data set called the Gridded Relative Deprivation Index, or GRDI version 1. Module 3 on disasters and wildfires. We're very lucky to be able to kick off with many of you fine folks at the ESIP summer meeting last July in North Carolina. So again, we're following the same pattern here, where we're hearing from subject matter experts on their expertise, and then brainstorming lessons with the crowd. So some of the takeaways here is that we have a data science life cycle, we have an open science ecosystem, and disasters is also a disaster life cycle. So kind of a lot of moving parts there to try to whittle down into something. This module, it's still pretty early in development, but we are working on lessons on the analysis of Canadian wildfire impacts from a couple of summers ago. We have an image here that was collected from a drone of a washed out road that will become part of lesson 2 on how to do an impact assessment, and what can you do with satellite data, and then what are the limitations of satellite data, where you may need to go out into the field with a drone to capture more high resolution information. And then we're in early stages of developing a lesson 3 looking at low elevation coastal zones, which those are areas contiguous to the coastline that are below 10 meters elevation above sea level. Many people think of low elevation coastal zones as areas where they need to consider ideas like managed retreat. Again, a focus here is to look at the fitness for use of different types of data sets to answer the question at hand. So the 4th and final module, we will be kicking off this March at AAG in Detroit. So if you're going to be at AAG, I hope to see you there in this session, where we'll kick off the climate and agriculture module. But we already have some interactions underway with a great group of volunteers who are interested to contribute to these thematic areas. One of them being the NASA ACRES program, which is out of the University of Maryland, and another one being the NSF AI Institute for Research on Trustworthy AI in Weather, Climate, and Coastal Oceanography, or they also call it AI2ES. So it's been amazing, actually, and this segues into my next section about how open science has brought more people to the table in school. So what is it about school that really makes it an open science project?
5 minutes.
Thanks, Elizabeth. So our project, we've focused on developing these materials using open science, right? So we've taken an inclusive agile development approach, which I mentioned the subject matter experts who, again, volunteer their time to help guide us in lesson development. We also have an open science team, which is made up largely of volunteers. Those are like the folks from NASA ACRES I just mentioned. The open science team, we do have a small number of stipends that we make available for them, but they've been really amazing. So I'm cognizant I need to speed up a little bit, but I want to mention this image here on the bottom right. It's from a training that my colleague Juan Martinez conducted for AmeriGeo Week that was, entirely in Spanish, and for many folks from the Ecuador Space Agency. There's over 100 attendees. We were able to show one of our lessons on water stress using online Jupyter notebooks, and it went off without a hitch. So that was one triumph for the team. Here's a list of the different open source tools we use. We'll archive everything in the DAX. We're developing the modules in GitHub using open frameworks like Porto and Sphinx. Our partners at 2i2c and James Monroe in particular have been, really supportive in helping us to create live environments to run codes. As I mentioned during AmeriGeo Week, we were able to run with 2i2c a Jupyter Hub for 100 attendees, and no one had a problem, which I think is amazing. For all of our meeting materials, we use Zenodo as an archive. So I think that, it's been exciting there that for a lot of our volunteers, when they get added to Zenodo, now they have something they can put on their resume, right? And they can say, hey, this is a publication I worked on, because now I have a DOI and a reference, a citation I can use. We also want to go to where the people are. So we publish our stuff on YouTube, and then we use ORCID. In particular, our engagement with National Louis University has been amazing. They were another TOPS-T awardee that was focused on delivering summer schools. In particular, Dr. Robin Moncrief and Dr. Antonio Tovar, I want to point out. With them, we were able to create a capstone program with NLU, where a bunch of volunteers have been contributing to this project. Actually kicked off a capstone last week, where we have these six students from National Louis University and MSI in Chicago. They're focusing on creating their own lessons. So we're thinking like community generated lessons. And also something that has emerged is our original lessons were quite long. The data lifecycle is very involved. So there's this need that came up for these, what we're calling bite-sized lessons, which focus very targeted on one specific lifecycle aspect. And then they prioritize examples with small sets of bite-sized data to get over some of the heavy lifts of downloading, several gigabytes of data. So this presentation was called a lessons learned presentation, and I'm just getting to the lessons learned here at the end.
1 minute.
Okay, thank you. But I know this is probably why a lot of people are attending. So I guess the number one lesson is that although open science is difficult to practice sometimes, it's very rewarding to interact with all of these different groups. I would say one thing for future people to think about when they're writing proposals is that there is a lot of overhead that comes with engagement and management. Because the team is always growing and changing, and there's different sets of capabilities, it means like handling their feedback and revisions. You have to be quite judicious, and it does take a lot of effort. Inclusivity is great, but sometimes people have very different technical backgrounds, which can create a challenge for you as a project manager. We hear a lot about quirky data sets. Quirky data sets can also cause a lot of issues. When we get into computing in the cloud and big data especially, there are options like 2i2c and GitHub Codespaces and Google Colab and many others. So figuring out which one to use can be a challenge. And, the sustainability of a cost model of running on someone else's system is a challenge we're still trying to figure out how to overcome. Because sometimes we want to use big data, maybe if they need to download it locally, it might be too big. Elizabeth, I hope that I can cut into the Q&A just a little bit just to finish this next.
Absolutely.
All right, thank you. There's been a huge demand for open science materials. So I mentioned, NASA Acres and the AI group from NOAA. They're reaching out to get involved and not just to consume the material, but to help produce it. And we've also gotten a lot of requests for in-person trainings that we're kind of trying to manage. When can we do them? Sometimes if you have a lot of diverse perspectives in the room, it leads to like a TMI problem, like too much information. What we found is that if you break into small teams, then that method of development with small teams has been an effective way to funnel down that information into something that's more manageable. And then finally, we come in as experts in data, so we have to be mindful of the assumed knowledge when we're creating curriculum. Because school targets undergrads and professional teams, there are going to be varied levels of prereq knowledge. So I think, as an educator, what you want to do is make sure the least common denominator is captured, and you're not going to assume knowledge any more than you have to. I think, like, in terms of the process of open science and Zenodo and recording our meetings, there's a lot of internal debates about which data should we use and why. That I think it's important to make them public. That really is the spirit of open science, is to do it out in the open. But then we found that because of all of these perspectives, we have to be really careful about scope creep. Although open science provides a lot of new ideas, you have to be judicious about when to incorporate them. All of a sudden, you've ended up somewhere you never intended to be. Of course, this has a lot of implications for proposal writing. If you have to be specific on effort with a line item, once you open it up to outside ideas, then the scope by its nature is going to creep. So I know I threw a lot at you in these few minutes. I'll just leave this slide up as I finish. This is our project team. The main funded element is Columbia University, but then we have a sub-award with iSciences LLC. I know Tom Paris is very active in the ESIP community, and another sub-award with Deborah Balk at the CUNY Institute for Demographic Research. And then we've had some real champion volunteers who have helped us a lot. Especially, I want to draw mention to James Monroe at 2I2C, who's been so supportive. And then Antonio Tovar and Akshay Mestre at National Lewis University have really added so much value to the project. So I know I've gone too long. Sorry about that, but love to open it up for Q&A.
Sounds perfect. So we have about 5 minutes or so. Do we have, okay, so Kelsey did post a question. What would be some examples of quirky data in these cases?
Yeah, that's a good question. So the one thing that I had in mind when I was writing up the slide was I mentioned in the water module, we have a lesson that utilizes data about lead in pipes in schools in New York State. Now, the thing that's quirky about that data we ended up actually building an R Shiny app for people to interact with it, because the data set itself was just not integrated to the extent that many NASA data sets are, right? So we're getting data from state agencies and counties, and there's also issues in definitions of things, like should we be worried if there's a lead in school pipes, but the sample was taken 4 or 5 years ago? Probably not. We need more information in those cases. So that's one thing I'm thinking about, is having to explain these data sets that are coming from diverse sources. Another example is dealing with multidimensional data from NASA that may originate in a NetCDF file that it take quite a lot of pre-processing to put it in a usable form. So in our lessons, sometimes we ate some of the pre-processing, handling the quirkiness in the data, and we provide to students something that has had some pre-processing applied. So I hope that answers your question.
It does. Thank you. It sounds like there are unsurprisingly many sources of the quote unquote quirkiness. And you sort of got to another question that I had, which is taking raw data and putting them into more usable forms, not even further actually than just extracting from a NetCDF kind of file, maybe to, something like, the most basic example I can think of is like a vegetation index, but sort of giving people even beyond the raw data, something that you can kind of generate for them to be able to analyze.
Yeah, and I'd say that's exactly right. So, you know, in some of these envisioned bite-sized lessons, you know, we'll be providing data that has been pre-processed for analysis. And I think one good thing to do when, you know, when you're teaching someone something that they've never seen before is you have to scaffold it through demonstrating, and you know, almost you do it for them and then they repeat kind of approach. So we try to, you know, encompass that in the learning modules.
Thank you.
Thank you.
So we have about 3 more minutes. Are there any other questions for Kit? Maybe the development of this model, any technical questions, how he created these various communities of practice. It's like very impressive with all the work that you're doing, Kit, with this.
You listen.
All right, we'll give it a few more seconds. Let's see here.
I guess while we're waiting, you know, our interaction with the folks at National Louis University, you know, it came out of there was a TOPS symposium that all of the TOPS T awardees, you know, oftentimes in the Roses, there's the condition that you have an annual meeting. So we had a TOPS T meeting where, you know, we had a good chance to talk with each other about synergies, and then, you know, a real champion in Robin Moncrief and Antonio Tovar, who had the need to run these capstone projects, and you know, we hit it off. So I think that there's a lot of value in personal relationships. But one thing I wanted to say that I don't have a slide on, that I think, you know, I've been a part of a lot of projects over the years that, you know, in the grant funding cycle, it ends after 2 or 3 years. And then the project, you know, maybe it lasts a couple of years longer, but then it goes away too. So we're really focused now. We're in year 2 of the grant, and we're trying to build out a community governance model so that there's a chance for the program to continue even in absence of additional grant funding. So I think that's so important to create the specific, you know, I don't know what to say, the guardrails, I guess, to enable a community to take over something like this. And you know, without our support from National Louis University, probably wouldn't be possible.
I want to mention, Lindsay put in the chat here something that I feel like is pretty important, saying, just want to give kudos to the point about not assuming prereq knowledge and catering to the least technical person. Technical workshops and instructors tend to run away quickly when there are some others in the room who are also very technical and who can leave others behind. I am guilty of this. You know, creating a safe space for users is so important.
Yes, I mean, I agree, and I think it's really hard that, like, when you know, when you've spent your whole career working in something, even to do the self-analysis, to be like, I'm assuming you know what this word means. So it takes a lot of time to suss that out. And one good thing about open science, though, is you can get the feedback from people who aren't specialists early and often.
I love that so much. I have been trying for this session to copy over some of the comments and attribute them to the person who posts them. So if you want to refer back to those at a later time. Thank you so much, Kit. I appreciate you. You're a rock star. Also, first day of class today, so you're juggling lots of things. Thank you so much. And we're at this time, we're going to go ahead and move forward, and I'm going to share my screen. Of course, everyone, the Padlet is there. Put your thoughts, your questions, and take a look and, you know, check the Padlet and see if there's anything for you there. And I am going to share my screen here. And so Elsa Culler, the Earth Data Science instructor from UC Berkeley, University of Colorado Boulder, sorry, wrong UCB, was supposed to talk with us today. She was having some technical problems, so she sent us a video, which I just received, and we're not going to have time to show it today, although Megan said that we can put it into the archives and share it out on the ESIP channel. And I have also added the link in the Padlet under the Earth Lab session. So I wanted to make sure that you're aware of that. And so it is here. And if we have some time at the end, which I don't think we're going to do, we will come back to it. All right, so the next thing that we are teeing up for is Climate Match Academy. This is Jenna Pearson's presentation, course director, and she provided us with a video as well. But I want to say Jenna is the co-founder and course director of Climate Match Academy, dedicated to growing and empowering the global collective of climate scientists through community-driven, accessible learning. So I am going to stop share and share another screen so bear with me as I navigate all this technology. And all right, so here we go. Share audio. Hold on one second. I'm going to share audio and all right.
Hello, everyone. My name is Jenna Pearson.
Can you hear that?
Yes.
Perfect. Okay. And I'm going to go on mute. So hopefully that doesn't affect the sound. If you cannot hear Jenna in just a moment, please let me know.
And I am the co-founder and course director for Climate Match Academy. I would first like to thank our sponsors and collaborators that are listed here at the bottom of the page, but in particular, give a shout out to NASA TOPS, for which Climate Match would just purely not exist. And so to walk you a little bit through our model and who we are, for those who haven't heard of us yet, Climate Match Academy is an inclusive, comprehensive program that's designed to train individuals from diverse backgrounds in computational methods for climate research. And we welcome participants with foundational Python and science skills, even if they aren't yet climate scientists. Through student-centered learning and hands-on research projects, as well as professional development opportunities, we aim to help individuals transition into or advance existing careers in climate science. Additionally, we aim to provide a clear pathway from completing our course to becoming a researcher or an industry professional in climate science through a range of post-course opportunities, which I'll discuss more in detail shortly. And so our course operates on a global scale with a global student base. Applicants from around the world are assigned to a pod based on three main factors. Their time zone, so we have 5 time slots available for them to choose from, and they pick their preferences that they would like to do the coursework in. It's 8 hours a day and for 2 weeks. And then there's the next priority for grouping students is based on their project topic interest. So this is what they would like to research during the course. And then finally, we group by seniority. So whether our students are undergraduates, graduates, or postdocs. And then finally, we do make some language considerations if there are enough students who select that they would like to, even though our materials are only available in English, they would like to be in a pod whose primary language is in their preference. And so each pod consists of approximately 14 students who are then divided into 2 smaller project groups. And each project group works on a single research project. And then teaching assistants are present during most sessions to provide guidance during all curriculum or tutorial sessions and a little bit of the project sessions. And then finally, we encourage peer-based learning throughout the course. So over the 2-week synchronous but virtual course that we offer, students meet daily with their pods for approximately 4.5 hours, during which they cover a diverse curriculum, including tutorials on topics such as paleoclimate proxies, ensemble methods, and the socioeconomics of climate change. And so a teaching assistant leads the pods through these sessions and afterwards spends additional time assisting students with their projects. And then the project time follows curriculum time, and it lasts for about 3 hours a day. And during this period, a specialized project TA with advanced, more topic-specific climate science expertise is also available for about an hour per project group to provide further guidance. And finally, we also integrate professional development activities throughout the project time where students engage with mentors and view videos on topics tailored to their interests. And so these are our materials. At the bottom of the screen, you'll find a link to our Jupyter Hub, or excuse me, our Jupyter book and GitHub repository. And then this snapshot on the screen showcases the start of a tutorial on climate modeling. And so students can access the course through our dedicated hub, which is through the rocket icon at the top there, which provides a fully equipped computing environment and resources necessary for completing tutorials and working on research projects. For added flexibility, the students can also open the notebooks in Google Colab or Kaggle. You can see those buttons towards the top left of the screen. All of our course materials are also just open source and community driven, which allows anyone to contribute updates or improvements upon review. Our materials are also CC BY licensed, which means that the community may use these materials in their own courses and study them even if they are not or do not take our synchronous NTA supported course every July. And then finally, we also iterate on the content to remake ourselves to ensure that it remains current and relevant. So just to touch on our users for a little bit now, I want to talk about who they are, some of the unique challenges they face, and then touch on how we address many of these issues in our model. So our students stem from a rich tapestry of scientific backgrounds. Around 25% of the folks who take our course over the last 2 years, 2023 and 2024, are unsurprisingly from earth science. But we also do have some strong participation from folks in other but related disciplines such as engineering and technology, as well as environmental science and forestry, as well as a number of other fields which are growing, and we hope to continue to increase those percentages with our targeted outreach strategies. Our students also come from a variety of career statuses and genders, so we have about a nearly 50-50 gender split, which is really exciting for us. And then also exciting to us is the number of genders that are starting to populate our course. So those are the ones that we kind of didn't have space to put the text on because it would have been too tiny to read. But I like to think of these par charts as really accordions where where part of our outreach efforts is to really expand all of those sections and equalize many of the gender categories. And we have a pretty even split among career statuses already, where those who take our course are typically undergrads, graduate students, and industry professionals. And our courses offer globally, so participants stem from a wide range of countries. As part of our outreach efforts, we focus on recruiting students from underrepresented nations, particularly those in low and middle income countries. Our goal is to increase accessibility to climate science tools and resources for these communities, ensuring that they have the opportunity to engage with and benefit from cutting-edge climate research and education. That said, many of our students do face challenges in our course. So for many of our students, financial constraints are a challenge when considering a course like this. And so to help alleviate these costs, we do offer regionally adjusted fees and tuition waivers that can cover some or all of the course expenses. Currently, we are refining our funding model to better support those who need it most, ensuring that financial barriers do not prevent students from accessing the valuable resources and opportunities our course provides. Additionally, there are many considerations we make for our students. About 2 to 5% of students have either unreliable access to electricity or Wi-Fi, or have a disability that prevents them from fully engaging online with the course for the full duration. And so to accommodate these, we offer a lo-fi track where students would check in briefly with their TA or pod for about 30 minutes to an hour on Zoom, and then the rest of the time they would work with their group and TA via Discord, which is our communication server. This alleviates the need to be on Zoom so consistently or frequently throughout the tutorial sessions for those without the reliable means or ability to do so. And so 30 of the students who answered yes to one of those questions regarding electricity, Wi-Fi, or disability said that they would like to have been on they would like to take this lo-fi track that we offer. And so there are also many factors that motivate our students to participate in the course. This particular question was select all that apply. So many students chose multiple answers. And the most common motivation is to develop new skills, followed by 50 to 70% of students reporting that they are participating for personal or professional growth reasons, or to facilitate advancement or a change in their careers. And so to help facilitate these desires of the students and help them achieve those goals, in addition to our course content, which helps students develop new skills and knowledge while honing their analytical, technical, and communication abilities, we do offer mentoring sessions that are tailored to the mutual interests of mentees and mentors. And so these sessions cover topics such as research concepts, PhD applications and industry job applications, etc., that our students all said that they would like to see or have present during these mentor sessions. And our goal is really just to ensure that students can learn from experts in the field and gain valuable insights on how to succeed in their next steps within the climate sector. And then finally, we aim to really bridge the gap between our course and the climate sector through our innovative Impact Scholars program. So the Impact Scholars continue working on their research projects under mentorship and with our resources, our computing resources, available for 6 months after the course, with the aim of producing an open access publication. So this program really just aims to support students as they transition out of our course into the broader world of climate science and further their contributions to the field. So thank you so much. I'm so sorry I was not able to attend this meeting in person. This is an amazing effort, and I really applaud the session organizers for putting this together. It is really just so important to making sure that we're identifying the needs of the community and working towards a common goal to make sure that those needs are met. And so I hope that if you have any interest in learning more about Climate Match, even just who we are, maybe you want to take the course, maybe you want to, use a piece of our model in your own models, or if you would love to collaborate and develop a partnership, we are open to all of those. So please reach out to me, jenna.pearson@climatematch.io. I hope to hear from you soon.
All right, that was great. I see that Doug Rao is here in the room with us, and Doug has been a mentor with this program. Doug, you have about a minute. Is there anything you wanted to say about Climate Match Academy?
No, I think Jenna covered everything. I was involved in the first iteration when it was founded, and really trying to go through the theme of from data to action, trying to embed the training of how to use this data, and then to address some things that people are interested in, especially with their own professional development. That's why we also have professional development activities and also impact scholars after that. And so that's some things that have been continued after the training during that 2 weeks, and working with CMIP and other programs to give the scholars of the CMA participants the opportunity to further explore the career options as well as the research and skill development.
Thank you, Doug. Are you still involved with Climate Match Academy?
I'm on the steering group for the academy and stepped away from the development and implementation of it.
Great. All right, Doug. Thank you so much. Are there any questions for Doug? All right. Well, at this time, I would like to ask for, thank you, Doug, by the way, ask for help from the ESIP group. I would like for us to, in just a moment, we're going to break out into breakout rooms. We have 5 breakout rooms. And give me 1 second while I try to navigate. Okay. We're going to return to the Padlet. And so I'm going to put that link in the chat. Actually, it's been shared already, but let me copy. I'm going to put it here. And so please open this Padlet. And okay, we're here now. We're going to be breaking out into 5 rooms. And actually, I see we just dropped 2. So maybe they're like, oh no, we've got breakout rooms. But please don't leave. Please, your voice is very important. So we may not need 5 breakout rooms. But nonetheless, we can certainly, why don't we do 4 breakout rooms instead of 5? And the idea here is that we go through these questions with our peer in the breakout room, and we put in responses to these questions. What have you heard today, whether it be in the morning session or in the afternoon session or both, hopefully, and bringing your prior knowledge and experience. Let's address some of these questions. And then what we're going to do is we're going to come back at, let's see here, around 2, probably earlier than that. Let's make it 2:45. 2:45, we'll close the rooms and then share and have a discussion. And yeah, so that is, yeah.
Really quickly, Elizabeth, can I suggest 3 breakout rooms just because we only have, I think, 10 folks, and it might be nice to have 3 in a room just to be.
Absolutely. Happy to. We'll focus on the 3 blocks here in that right-hand side of the Padlet.
Okay, perfect. And then you want to come back at 2:45, you said?
Let's do 2:45. And you're welcome to, if you want more time, let us know in the chat, but I think that would be probably plenty of time, and we'll come back and discuss.
Okay, I'm going to open the rooms now.
Thank you.
Mm-hmm. And if anybody needs help getting where they're going, let me know.
Okay, cool. All right. So it looks like they're back. Are they back, Megan? Okay. Yay. Thank you for sticking with us and doing the breakout rooms and talking. Sometimes that can be uncomfortable for folks and whatnot, but I appreciate you sticking with us. And I was just saying, shame on me for thinking that amount of time would give us enough time to get to know each other and share our ideas. And so hopefully you did have some time to get into at least 1 or 2 of those big questions. And I want to say thank you so much for putting your thoughts into the Padlet, and I just hit update on mine. I would like to call on Lindsay. Lindsay, would you mind addressing question number 1? What are the needs that our non-super users have for accessing and making action with our data? Is there something that bubbled up for you?
Yeah. So Elizabeth and I were in the same room together talking about this. And I was just reflecting a little bit on, specifically the non-super user and how even if you're interested or excited about building data skills and exploring these data sets, you might not feel professionally supported to do so. And so, I guess that was kind of the biggest thing that I'm thinking about is which of these models that were presented today give people the chance to kind of act on that passion, but in a way that makes them feel supported, just because, a lot of times we're putting out free resources and tutorials and things and just thinking that that's enough. But there's this kind of cultural element too of us just not rewarding data skills in the same way that we reward, publishing peer-reviewed journal articles. So yeah, that's kind of the biggest thing that stood out for me.
Room 1, did you have any thoughts about that same question that you want to share?
No, I think it's a great question. And I think that, like you rightly point out, Lindsay, like in academia, people are rewarded for publications. They're not necessarily rewarded for learning how to use a new satellite sensor or integrating some new data set that other people could use. I think that, you know, trying to meet people where they are is the only way that I know how to kind of make an impact. So I think, you know, I don't know if it's a linear relationship, but there's certainly a relationship between the amount of time you're getting out there and meeting with new people face to face, and, you know, introducing them to these new topics in a digestible way, and the uptake and success of the, you know, the products. So I don't know. I don't know if that really gets at the question, but those are some of the thoughts that I had.
Thank you, Kit. You know, one of the words that you used is really significant to me as a former teacher is the term digestible, right? Like, how do we figure out what is digestible? What do you have any advice about that?
Yeah, less is more is the, you know, I'm very guilty though of throwing a whole pile of information. I think I did it in my talk today, but when it comes to like digestibility, I think it's really like less is more, and, you know, thinking about the cognitive load that we're putting on people, like, you know, how much text are we using versus images? You know, are we taking sufficient time to change our mode of thinking? So I know, like in an in-person class, it's like every 10 or 15 minutes you want to shift, whether it's talking to your neighbor or listening to a lecture or doing something with your hands. So I think that is how you make something more digestible. It's just by breaking it into bits.
Yeah, that's great. Are there any models that you learned about today, whether it be in the morning session or the afternoon session, that you thought, huh, I really like that. That's got some legs. I think I might want to explore this approach to addressing needs of users. Did you guys identify anything that was of interest?
So, Elizabeth, our group got pretty concrete in terms of thinking about instructional materials development and, you know, the 3 to 5 minute video, the video with slides that you can actually click on the links, the idea of putting a find, you know, control find in online documentation. We went down the road of thinking about very concrete kinds of models, and it also goes back to question number one of ease of use. What do you want when you're having difficulty with a data portal or a data set? Very quick ability if you're stuck. If you can't find a certain button, you want to really quickly find it. So I don't know that that was necessarily a model presented today, but that's just where our group went in our
Yeah.
thinking.
And that's really important to think about those things. And there's developers I'm thinking of like at Gesdisk at NASA Goddard who would love to know what you're thinking about these tools and services. So maybe thinking in a more holistic approach. I know that Lindsay mentioned the ESOL program, something interesting that she really liked. Lindsay, would you mind sharing that?
Yeah, I was just gonna say, because something you added on to it, I think is really exciting, and the model of paid internships to me was particularly interesting because I think it kind of gets over the issue I was having before, which is, you know, people not feeling supported, and if you're given essentially the time and money in order to invest in the skill, it makes it a little bit easier. And Elizabeth added that, you know, why don't we consider paid internships for community college professors or, you know, high school teachers, because then they're learning this skill and now they're able to bring it back into their own classrooms and even expand the impact of what they learned in their internship. So yeah, I really like the idea of that model.
This is Carla again. I'm a big proponent of paid professional development. In the business world, that happens just automatically. If they want you to learn a new skill, they pay for it. It doesn't happen a lot of times in our fields or in preparing for our fields for undergraduate, K-12, whatever it is. Often that paid professional development piece doesn't happen, but it's really critical.
Are there any, oh, sorry, Kit, go ahead.
Sorry. I was just going to say, in the school project, we had budgeted for stipends for people to be part of the open science team. And then we distributed them in a needs-based way, where if someone said, hey, I need some support in order to spend time on this, can I use a stipend? What we found is that the people who have received stipends, they put in just so much time, so much more than actually we were able to give them a stipend for. So I think there's something important there in the development of projects as well, where in open science, if we're reaching out to the community and crowdsourcing ideas, if we're able to also compensate people for their good ideas, my experience in this project has been they go above and beyond at that point to do even more.
That's great. One of the things that Lindsay said when I was talking in the breakout room is that free resources are really great, but if you don't have the time to use them, you don't get to use them, right? And so they may not have a limit in their passion, but are limited by their time, money, and maybe energy as well. So, buffering that and providing support. Maybe that's something, Carla, for the ESIP education piece to take back as a potential action item of a way ESIP could support the community.
Yep, I'm ready and willing. That's why I'm here, to make connections across, we're all about education. And we do have a very small stipend thing that we put in our budget every year to give teachers the opportunity to implement a data set or a educational tool that we've shared with them in the classroom. And so that's a nice thing, but maybe we can find ways to put more of the budget towards that kind of thing, or look for, an organization that might be willing to support ESIP in that endeavor.
That's great. Anything else? We heard about Space Apps challenges. We heard about Higher Sense, working with tribal communities. We heard from Aaron. Aaron was talking about how vulnerable of an experience that was, and learning what he didn't know and about different communities. Did any of that stick out with you in terms of communities of potential, maybe some work that you would want to do on the front end, or any of that? Did any of that bubble up for you as being something of interest? And that's okay if it didn't. All good. We have really about a minute left. I want to say thank you so much for taking your time today to explore these different models of excellence. And your work is really important. And so if there's a way that we can support you, if I can be of assistance, please reach out. It's been great to be your host today. So, and thank you to all my friends, and Carla and Kit, and that are here and working on this. So thank you for being here.
Thank you, Elizabeth. It's not easy to organize all the logistics of all the speakers, and you do a really great job of it.
Thank you, and good luck with your semester and your new job.
All right, thanks.
All right, Lindsay, it was great talking to you. Thank you all.
Thank you.
Thank you.